we're going to move on to section 7.2, which is solving systems of linear equations by graphing. So just to remind you that a system of linear equations is a set of two equations that have two variables. So we do call that a 2x2 system because there's two equations and two variables. You could have more of each, but not in grade 10. We just do 2x2. Two equations, two variables. So basically what we're looking for is we're trying to find an x and a y that work in both equations. So if you think of this on a graph, you guys, the x and y that would work in both is where your lines cross each other. That's the only spot where the x and the y would work in both equations because it has to be on both of your lines. So again, what I'm looking for is where your two lines cross each other. So let's take a look at how then to graph these. Okay, so here we have two equations in a linear system that are graphed on the same graph. What are the equations of the graphs? So you guys remember that when you're doing an equation, the easiest format is y equals mx plus b. When you're doing mx plus b, the b represents the y-intercept, and the m represents the slope. So my y-intercept is running here. This is the y-axis. So I'm looking here that this line has a y-intercept of 5, and this line has a y-intercept of 1. I'm just going to start with the first line here. I'm going to call this L1. I'm just calling this line 1. Okay, line 1 in mx plus b, let's look at the slope. So remember, slope is rise over run. So this one goes up 1 and over 1, up 1 and over 1. So the rise is 1, the run is 1, meaning the slope is 1 over 1. So if I put this into the equation, we'd get 1x plus 5 for the equation of line 1. Again, the y-intercept is 5, the rise over run is 1. Then let's look to line 2. I'm going to call this other one line 2. Line 2 has a y-intercept of 1, but the slope goes down 1 and over 1. Down 1 and over 1. So I'd say that line 2 has a negative 1 slope, because it's going down 1 and over 1, and then plus 1 for a y-intercept. So remember that using mx plus b is how we can make the equation of a line. So where do these two graphs cross? Because the point of intersection is going to be my answer. So I look here, it's got an x value of -2 and a y value of +3. So the point of intersection is -2 and +3. I also want to point out that the -2 is the x and the 3 is the y. So that means that this is our answer. -2 for x and 3 for y is our answer, because that's the point that's on both lines. So explain why these coordinates are the solution of the linear system. It's because this point is on both lines. Now remember that you kind of have two options here. Either your lines cross once or they never cross. So you just have to pay attention that if your lines are parallel, and what do you know about the slopes of parallel lines? Same, right? So they'd have the same slope. So if you have lines with the same slope, you won't get an answer because those lines will never cross each other. Let's try actually graphing one on our own here. It says solve the linear system. So to do this, we're going to use x and y intercepts. So for the first equation, we're going to find the x-intercept. And remember, to find an x-intercept, you set the y value equal to 0. Because on an x-axis, all the y values are 0. So if I put a 0 in for y, I get x plus 0 equals 8, which means x equals 8. So that's my x-intercept. To find a y-intercept, we do the opposite. We set x equal to 0. So here, if I put a 0 in for x, we get 0 plus y equals 8. So my y-intercept is also 8. So I have an x and a y-intercept, both are 8. So then for the second equation, we do the same thing. Again, we're just finding our x and our y-intercepts. So to finish this off, we have to put them on the grid. I'm Alright, so now once we put our grid, we've got our grid made, all we have to do is put on our intercepts. So in blue, I'm going to make my blue graph. My blue graph has a y-intercept of 8 and an x-intercept of 8, and then I have to connect my dots. I'm going to try to make a nice straight line. And then my red graph goes from -7 to positive 4.6, and again I'm going to connect them. Now you should notice where your two lines cross. Okay, where they cross. And where they cross, it actually should be a nice spot that they cross at in this example. It's got an x value of 6 and a y value of 2. So that means that my solution is 6 and 2. So the 6 is our x, the 2 is our y. We now have to verify that. So 6 plus 2 equals 8. Yes, that works. And you do have to verify in both equations. So now let's check this one. 3 times 6 minus 2 times 2 equals 14. This is 18 minus 4 equals 14. Yes, that works. So now that both of my checks worked out, I can circle my answer and say that yes, that is the solution where both of my graphs would meet up and they would cross.